The next network application we are going to learn about is DNS, or Domain Name System. ID number uniquely identifies people, but we, humans, use names to identify people we know. We talked about end systems, hosts, and that they are identified by IP addresses. However, similar to people and ID numbers, it is hard for people to remember IP addresses. So we use host names to remember the hosts we work with. For example, you remember google.com or yahoo.com, but you might not know their servers' IP addresses. However, when we use google.com and yahoo.com as hosts we want to reach, these names have to be mapped to their IP address so that our datagrams could reach them. The primary function of DNS, or Domain Name System, is to do the mapping between host names and IP addresses. DNS is a distributed database implemented using a hierarchy of many name servers communicating with each other to map host names and IP addresses. It is an application layer protocol that provides a network layer functionality. As you will see in the discussion shortly, the complexity of this protocol is at the network's edge. DNS provides a number of services. The best known of its services is translation of host names to IP addresses. So when you want to reach a server and you only know the name, DNS system comes to help. It also provides host aliasing. A host with more complicated host name may have one or more alias. Host aliasing is used to find a simpler host name for more complicated host names. For example, if the host name is westcoast.region.sumstore.com, this could be translated to a simpler sumstore.com. The more complex name is called canonical name, and the sumstore.com is the alias. Aliases, if available, are more mnemonic than the canonical names. The aliasing could also be done for mail servers. DNS could also be used in load distribution among replicated servers. Busy websites have more than one host serving the clients of the website. Therefore, the same request could be directed to different IP addresses. In DNS responses to a query, all of the IP addresses for a server are returned, but the order of listing the IP addresses is different. Since the clients usually use the first IP address in the response, this performs load balancing among the servers. A question that might come up with the DNS service is about its architecture. We mentioned that DNS service is a distributed database implemented in hierarchy of many name servers. Why don't we just implement the service in one central place and send all the requests to the same server? The short answer is because it won't scale. First, that single server would be a single point of failure. This would leave all the hosts unserved in the event of any failure, like a crash. Second, the volume of traffic sent to that centralized point will be unmaintainable huge. Third, the centralized server will be located in one place, and therefore, geographical distribution of requests will cause large amounts of delay. Fourth, ensuring all records are correct and updated will need huge maintenance efforts. Therefore, the centralized solution is not scalable, and therefore DNS is distributed by design.